The artificial intelligence industry in 2026 is locked in a relentless race, ingesting massive oceans of text, code, and media. This chart shows the escalating numbers in the current context window war. Google's Gemini 2.5 Pro consumes 2 million tokens. Claude Opus 4.6 handles 1 million. Then Llama 4 Scout claims a massive 10 million token capacity. The core product being sold here is a concept of infinite memory. The industry treats infinity as a physical noun, a warehouse that can be progressively stocked with more and more tokens. Measured, the driving assumption is that if you feed a system enough text, its sheer reading capacity will eventually accumulate into an understanding of everything. But behind the software promises, these companies are colliding with strict physical and economic constraints in their hardware. This graph illustrates the attention mechanism's compute load, which scales quadratically. Double the context window, and the required processing power roughly quadruples. Translating this to server load, maintaining the memory cache for a single user at 1 million tokens demands 15 gigabytes in space. Tech companies generally treat this quadratic barrier as an engineering annoyance, something they can eventually patch over with enough capital and advanced silicon. This brute force approach assumes that piling up more physical resources can eventually bridge the gap to a true limit. But as the gap to the asymptote shrinks, the costs of simply moving forward become unsustainable. In 350 BC, Aristotle divided the concept of infinity into two distinct categories to explain how things scale. The first is potential infinity. This is a process that never stops, but remains finite at every single moment. It is like counting numbers one by one. There is always a next number, but never a final one. The second is actual infinity. This refers to the completed totality, the entire count, grasped completely and all at once. This visualization applies to AI via a Banach contraction. The sequence climbs continuously toward a hard ceiling, shrinking the gap by the golden ratio rate. Each new iteration remains potential infinity. It approaches the boundary endlessly, never securing the actual infinity it courts. When an AI model scales from 1 million to 10 million tokens, it simply adds iterations. It extends the length of the data sequence along an endless asymptote, mistaking a longer sequence for a true limit of understanding. The limitation of the current AI race is it only increases length, indexed by integers. It endlessly adds one more step, plodding forward on a flat line that can never, by its own rules, arrive at the limit. Moving from simple accumulation to true comprehension requires a dimensional shift to a concept called depth. This requires moving beyond the sequence of steps and into the ordinals, the mathematics of self-reference. This diagram illustrates the shift. To reach the limit where a sequence stabilizes, the system must observe its own iteration. At this fixed point, the system's model of reality remains stable, even as it observes the act of its own processing. Depth is reached by the loop turning on itself. True understanding is a change of the line, not a longer walk down the integers. This model shows the projective identity defined in ODTOE. On a projective line, absolute zero and absolute infinity connect. They are mathematically equivalent. For a finite observer, having an empty context and an infinite one are the same unreachable point. Applying this to the current market, Llama's 10 million token window is mathematically no closer to genuine comprehension than Claude's 1 million token model. Counting to 10 million leaves you exactly as far away from the end of the integers as counting to 1. Both are infinitely distant from the limit. The current industry continues to chase this unreachable pole, pushing capacity down a sheer cliff of quadratic compute costs. This pursuit stems from viewing infinity as a static warehouse to be filled. But the ODTOE framework suggests that this approach confuses quantity with quality. Infinity functions as a verb. It is the active, dynamic state of convergence and self-observation, rather than a static destination. The future of machine intelligence does not rely on how long a system can read a sequence of tokens. It depends on how deeply it can look at its own observation.